In this video, I'm going to take a look at exam revision for Surds. Now what we're going to do here is just work through some exam style questions for Surds. If you are feeling confident, do pause the video and work through the questions as we go. But if not, don't worry, we'll work through those together. So getting started with the very first question here, we're asked to expand and simplify. So this shouldn't be too challenging, hopefully. All I'm going to do here is use FOIL to expand these two brackets, and then we're just going to simplify. So starting off with the first two terms multiplied here, so I'm going to take this 4 and multiply that by 4 again here, okay, because it's the first two terms. So 4 times 4 would give me 16. Then we do the outside term, so I'm going to take this 4 here and multiply it by positive root 5. So in that case, I'm going to get 4 lots of root 5, so plus 4 root 5. Then we multiply the inner terms here together, so we're doing the I of FOIL here, so first, outside, inside, last, so we're doing the I now, so minus root 5 times 4. And in that case, that's going to give me minus 4 root 5. So we get minus 4 root 5. And then finally here, multiplying the last terms together. So I've got this minus root 5 times that by positive root 5. And in that case, I would get minus the square root of 25, which would give me minus 5 there. So what we need to do here now is simplify. Well, clearly there's 4 root 5 minus 4 root 5. That would become 0, so they'll just cancel. And what I get left with then is 16 minus 5. So in that case, 16 minus 5 would give me 11 there. Okay, and that's simply our solution to the very first question. Taking a look at the next one here, pretty similar. So this time we're asked to express 5 minus root 6 all squared in the form of a plus b root 6, where a and b are integers. It doesn't look quite the same as this, but it is once we write it in the correct form here. So this 5 minus root 6 is all squared. So what I can do then is write that as a product of two brackets. What we're going to get here is 5 minus root 6 times 5 minus root 6, like so. Okay. And what I'm going to do now is just expand it again, just like we did for the very first question, and simplify, and we should get something in this form here. When multiplying the first two terms together, 5 times 5 would give me 25. So 5 times 5 gives me the 25. Now I take the 5 and multiply it by minus root 6. So in that case, I'm going to get minus 5 root 6. So minus 5 root 6. I've then got minus root 6 times 5. So again, I'm going to get minus 5 root 6. Okay, so we get another minus 5 root 6. And then finally, we've got minus root 6 times minus root 6 there. Okay. Now just be very careful here, because I've got a negative number times by another negative number, then it becomes positive. So what I'd get there is positive, the square root of 36, which would give me plus 6 there. So we get positive 6. And what I need to do now is just simplify here. So I've got 25 plus 6, that would give me 31. So we get 31 there. And then I've got minus 5 root 6 minus another 5 root 6. So in total, once we collect like terms, I'll just simplify here. I'm going to get minus 10 root 6 there. Okay. And there we have it. So what we can see here then is that a, in this case, it's a plus b root 6. So a must be 31 and b must be minus 10. Now we're not asked to give those values of a and b, but it is a good habit to get into. Okay, so there are our solutions to question 2. Moving on to this question here now. So what we've been given here is k, and k is equal to this expression here. And what I want to do is show that k can be simplified to give a root 5 here, where a is just an integer to be found. So where do we begin with something like this? Well, what I'm going to do here is just evaluate these squared brackets individually. So we start with 3 plus root 20 here. So 3 plus root 20 all squared. And what I can do is I can write that as a product of two brackets, because that's all that is there. Okay, so that's 3 plus root 20 times 3 plus root 20 there. Okay. So if I just expand these now using FOIL again, just like we've been doing for the previous questions. So 3 times 3 would give me 9. We then do 3 times root 20, so that would give me plus 3 root 20. Do the same again here, so root 20 times 3, and again I just get 3 root 20 there. And then finally root 20 times root 20. If I'm taking the square root of a and I times it again by the square root of a, I just simply get a. Okay, in this case I would just simply get plus 20. So what I want to do now is simplify here. I've got 9 plus 20, so that would give me 29. So we get 29 there. And then 3 root 20 plus 3 root 20, well, that would give me 6 root 20 in total. So we get 29 plus 6 root 20. Okay. What I'm going to do now is evaluate this bracket here squared, because what I want to do is evaluate that bracket squared individually. And then we're going to subtract it from this one here, which we already know, we've simplified that. So let's evaluate 3 minus root 20 now, all squared. So again, we can write that as a product of two brackets here. So that's 3 minus root 20 times 3 minus root 20. So again, just using FOIL here, 3 times 3, I get 9. 3 times minus root 20, so I get minus 3 root 20. Minus root 20 times 3, again, I just get minus 3 root 20. And then finally, minus root 20 times minus root 20. So just be very careful with the signs again here, because it's a negative number times by another negative number, then the result will be positive. And I just simply get positive 20 there. So plus 20. And all I'm going to do here again is just simplify. So 9 plus 20, I get 29 again. And then minus 3 root 20 minus another 3 root 20, I get minus 6 root 20. Okay. So let me use colors here just to highlight what we're going to do. So I'm going to take this part that we've just evaluated, which I'll kind of shade in blue here, and we're going to subtract that from this part here in red. Okay. So if we do that on one line then, what I'm going to get here is 29 plus 6 root 20. So 29 plus 6 root 20 minus, and I'm going to put this in a bracket just to show why. You have to be very careful with the signs here. So 29 minus 6 root 20. So minus 6 root 20 there. And I think doing the brackets here is really important because it just shows why you have to be careful with your signs. So 29 minus 29, well, they're just going to cancel. Okay, that's fine. I've then got 6 root 20 minus minus 6 root 20. And this is why we have to be careful. Because what I've got here now is 6 root 20 minus minus 6 root 20. So once I evaluate this here, it's going to be 6 root 20 plus 6 root 20, because subtracting a negative number becomes addition, positive. I get 6 root 20 plus 6 root 20, and in total then we get 12 root 20. But we're not done here because the question is in the form, or the solution is in the form here, k is equal to a root 5. Well, what I've got here at the moment is a root 20, okay? So what I need to do is simplify this root 20 here. So what I'm going to do is I'm just going to clear some room at the top here just so we can finish this solution off. Let's just clear some room up here. Shouldn't need too many lines to do this. Just clear one more line here, okay? So, like I said, at the minute we've got 12 root 20. We need to make it in this here, okay, in this form, so a root 5. So what I need to do then is simplify root 20. So root 20 here, we're writing that as a product of two surds, where one of those surds is a square number. I can write this as root 4 times root 5, okay? We know root 4 is equal to 2, so root 20 is the same as 2 root 5. So in that case, if I've got 12 lots of root 20, but we can write root 20 as 2 root 5, then what I've got here is 12 lots of 2 root 5. Okay. I expand this now, so multiply 12 by 2, and I simply get 24 root 5 there. Okay, so in that case, k is equal to 24 root 5, where where a here is that integer. So a in this case is equal to 24. And that's our solution there. So let's just highlight that. And there we have it. So that's our solution to that question there. Moving on to this question here now, we're being given the square m, which has an exact side length of 10 plus root 5 centimeters. We just want to find the area of m. So what I do here is I just do a little diagram. It doesn't have to be perfect, but just so we can see what we're looking at. So that's my version of the square. Now we're told an exact side length is 10 plus root 5 centimeters. So if you think about this, this is a square It doesn't really matter where you put the length here. I'll put it at the top. So 10 plus root 5 centimeters. Okay. So I want the area. And remember, to find the area here, I take a length and times it by the width, for example. Okay. So clearly, like I said, it's a square. So each side here will be the same. So that will also be 10 plus root 5 centimeters. So to find the area here for M, that's going to be equal to 10 plus root 5 squared. So 10 plus root 5 squared. So writing this now as a product of two brackets, we get 10 plus root 5 times 10 plus root 5 there. So multiplying here using FILE or any method that you're familiar with, 10 times 10 would give me 100. I then do 10 times root 5, so that would give me 10 root 5. And then root 5 times 10, I get another 10 root 5 there. Moving on to the last term here, multiplying these last two terms together, root 5 times root 5, that would give me positive 5 there. So all I need to do now is simplify here, and that would give me the area of M. So 100 plus 5, that would give me 105. I've then got 10 root 5 plus another 10 root 5. So in total there, we've got 20 root 5. Okay. And remember, this is area. We've got the area of a square here. So what I'm going to do, put this in brackets and also give our units here. Okay. So we're working in centimeters. So this would be centimeters squared there. Okay. Because we're talking about area. So that's the area of M there. Okay. And there we have it. So that's our solution to that question. Moving on to the very last question now, we're asked to show that 1 plus 2 root 5 over 2 minus root 5 can be expressed in this form here. So a plus b root 5, where a and b are integers to be found. So remember, an integer is just a whole number, can be positive, can be negative. So we won't worry about that too much. But where do we begin with this? Well, what I see straight away is we have a surd in the denominator here. Okay. Now, it's very likely that if you see a surd in the denominator, you're going to need to rationalize the denominator at some point. And because we've just been given this expression here, this fraction, and we're asked to express it in this form here, there's nowhere we can really start other than just actually rationalizing the denominator here. Now, because this is a surd and another number like this, so it's either a sum or a difference, what I need to do is multiply it by the conjugate. Because we're doing 2 minus root 5 here, then we times top and bottom by 2 plus root 5. We take the opposite sign there. Okay. So we times the top by 2 plus root 5, do the same for the denominator as well. Okay. So if I write that out more formally, what I've got here then is 1 plus 2 root 5. And we times that by 2 plus root 5. Like so. And this will all be over 2 minus root 5 times 2 plus root 5. We just write this out here in full. That's what we'll get there. Okay. So what I need to do now is just multiply using FILE here, both with the numerator of these two brackets, and then do the same with the denominator here. So if I start with the numerator, I've got 1 times 2, so that will give me 2. I then got 1 times root 5, so that will give me 1 lot of root 5. We get plus root 5 there. I then got 2 root 5 times 2. So if I've got 2 lots of root 5 and I times it by 2, I've now got 4 lots of root 5. Okay, so we get 4 root 5. And then finally, 2 root 5 times root 5 here. So just be very careful with this. It's very easy to make a mistake. So 2 root 5 times root 5 here. Well, root 5 times root 5, that would give me 5. And then we're doing 2 times that. So 2 times 5, that would give me 10 there. Okay. We get plus 10. So that's a numerator. We'll come back in a moment to simplify that. So we evaluate the denominator now. What you might notice here is this is the difference of 2 squares. So we can save a bit of time here because all I actually need to multiply is 2 times 2. So 2 times 2, and then minus root 5 times positive root 5. So 2 times 2 is 4. And then minus root 5 times positive root 5, that would give me minus 5 there. Okay, so minus 5. So if we simplify individually here, if we start with the numerator, I've got 2 plus 10, so that's 12. And then I've got root 5 plus 4 root 5. Now in front of this root 5 we don't write, but there's a 1. I've got 1 log root 5 plus another 4 root 5, so in total we have 5 root 5. Like so. Okay, so that's our numerator simplified. The denominator here is just 4 minus 5. So 4 minus 5 would give me minus 1 there. So in that case now we can express it in this form here. So if we're dividing by minus 1, signs will just change here in the numerator. So we're going to get minus 12 minus 5 root 5 there. Okay. And notice now it's in the correct form here. It's a plus b root 5, where a and b are integers. So in that case, if we identify the values of a and b here, a is minus 12 and b is minus 5 there. Okay. So b is minus 5. And there we have it. So that's our solution to that question. And that brings us to the end of this video on exam revision for Surds.